Hey everybody, here goes a video on vertex form of quadratics and the transformations. So, vertex form of a quadratic is a times x minus h squared plus k. So, sounds like a bunch of fun, but what does it all mean? Well, h is your horizontal shift. Now, that's going to be opposite of what you think, and you'll see why in a minute. So, that's your horizontal shift, again, opposite of what you think. So, if it's plus, it's going to go to the left. If it's minus, it's going to go to the right. You'll see why, okay? And we have a vertical shift. That's how far you're going to start up and down. So the vertex of a vertex form parabola or quadratic equation is going to be h comma k. And see, this is x minus h, and that's going to give you a little hint of why it goes in the opposite direction. Now, the crazy thing here is all the different things A can do to a graph. It can stretch it vertically, it could compress it vertically, it could stretch it horizontally and compress it horizontally, it could make it open up, and it could make it open down. It does all sorts of different things. So one thing you need to know is if A is positive, it's going to open up. If A is negative, it's going to open down. Okay? Now, what happens if A is outside of the parentheses and it's bigger than 1? It's going to stretch it vertically. But if it's a fraction between 0 and 1, so 1/2, 2/3, not 5/4, but 4/5, as long as it's smaller than 1, it's going to compress it vertically by the scale of A for both of these. Now, if A is inside, funnier things are going to happen because the A value is first going to be multiplied to the x, and then it's going to be squared. So that's going to do all sorts of different things. So it's a little bit opposite. If A is bigger than 1, it's actually going to compress it horizontally, or towards the y-axis. And same thing if it's a fraction, it's actually going to stretch it horizontally. And the scale is the reciprocal of A. Okay, so it's going to make a lot more sense once we go through some examples, so let's go do that. Now, for all the graphs that we're going to talk about, we're going to use our parent graph, which is a standard f of x or y equals x squared. Okay, whenever there are no transformations, that is called a parent graph. So this is just a traditional or typical x squared graph. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, negative 3 squared is also 9. As you can see, we are symmetrical about the y-axis because we haven't moved anywhere. So what we're going to do now, in all of the graphs we have here in gray, I have the parent graph so you can kind of see what's happening. So what we're going to do is start talking about the different transformations. Now remember, if there's just a negative x, the parentheses goes around the x. The parentheses is always going to go around the x if there are none listed, and just the x. If I want something else in the parentheses, I've got to give it to you. So I just wanted you to see that. I wanted you to watch me put the parentheses in. So, what happens if 0 is squared and then we multiply it by a negative sign? Well, it's still going to be 0. What happens if we take 1 and square it? We get 1, but if we multiply it by a negative, we get a negative 1. If we take a 2 and square it, we get a 4, but if we have a negative out front, it's going to give us a negative 4. So I wanted you to see that a negative will, in fact, flip or reflect the quadratic over the x-axis. Because once we take all the x values, we're going to multiply it by a negative, so all the y values will become negative. Okay? The next one, what does a plus 2 or a vertical shift do? Well, we'll talk about, of course, a parent graph. 0 squared is 0, 1 squared is 1, but what happens if we were to take 1 squared and add 2 to it? 1 squared plus 2 is going to give us 3. So let's go back to that 0. 0 squared is 0 plus 2 is 2. And let's go to a 2. 2 squared is 4 plus 2 is 6. So we go to 2 and we go up to 6. And then if we were to go to 3 squared is 9 plus 2 is 11. So we would be right up here. As you can see, basically the only thing that happens to every single point of the parent graph, it just gets 2 higher. That's because we are just shifting the entire parabola vertically. So that is a vertical shift. So the horizontal shift, I said that one's going to be a little bit different. If you were to think about this, you'd say, oh, that looks like it's just going to shift it to the right 4 units. But here's why that's wrong. Let's take a 0 and put a 0 in here. 0 plus 4 is 4 squared is 16. So when x is equal to 0, this graph is all the way off the chart. If you were to say 1, that would be 1, and that would be 25. That's even farther off the chart. So you're thinking maybe this is just 4 units to the right. Well, go ahead, try 4. 4 plus 4 is 8, and that's going to be 64. So we got to start going backwards. This is why it's a shift of 4 to the left. Plug in a negative 4. If x is negative 4, negative 4 plus 4 is 0, and 0 squared is 0. That's how you get back down here. Negative 3 plus 4 is 1. 1 squared is 1. Negative 5 plus 4 is a negative 1 squared is still a 1. So now you can see that basically this entire graph has been moved 1, 2, 3, 4 places to the left. 1, 2, 3, 4 places to the left. You can go all the way up here. 1, 2, 3, 4 places to the left. So that guy was a negative 7. Negative 7 plus 4 is a negative 3, and negative 3 squared is 9. So that's why everything gets moved in the opposite direction when it is inside the parentheses. Okay? So when you look at this, if you're asking for the horizontal shift, it's 4 to the left, not 4 to the right, and there's why. Let's talk about that a value for a little bit now. Our a value here is 3. It's outside of the parentheses, which means we're multiplying everything that comes out of the function by 3. So 0 squared is 0. And 0 times 3 is still 0, so our x value of 0 is still going to give us 0. But now let's try 1. 1 squared is 1 times 3 is 3, so we already are jumping up much faster. 2 squared is 4 times 3 is 12. We're already off the chart. Okay, and of course, using the axis of symmetry, we already know where the other 2 points are going to be. So that's why this is vertically stretching this entire parabola up by a scale of 3. Everything that we graph is going to be 3 times increased stretching vertically. Okay? So now let's see what happens when we use a 1/2. That means half of it is going to be, so half the value. So 0, of course, is 0. 0 times 0 is 0. We got that by now. But what happens when we do 1? 1 squared is 1 times 1/2 is only 1/2. 2 squared is 4 times 1/2 is 2. So where we would usually be up at 4, we're now only down at 2. And the same thing would happen if we were to go backwards as well. So half of 9 would be 4.5. So this is why when you are multiplying or a by a fraction smaller than 1, it compresses the graph vertically because we're multiplying all the y values by 1/2. Okay? Now this is the one that's the curveball. Again, it's opposite of what you think because the a value is inside. So if we were to go look at 2 times x minus 2, we're messing with the x values now. We're not messing with the y values. So if we were to go and say that x is 0, now you're going to think about this in terms of shifting 2 to the right. Watch what happens. If we put a 0 in here, that's 0 times a negative 2, or minus 2, which is going to give you a negative 2, squared is 4. Okay, so if you plug a 0 in here, you're going to get 4. Now let's put in a 2. 2 times 2 is 4, minus 2 is 2, and 2 squared is still 4. Okay, so see what just happened there? We just took the width and we compressed it. Even though this is a much bigger a value than what you would think, it's compressing it. Let's try a 4. So 2 times 4 is 8, and 8 minus 2 is 6, and that would be 36. So we're way off the charts already. So why don't we try a 1? 2 times 1 is 2, minus 2 is 0. So 1 brings us all the way back down to 0. So notice how it messed with the shift a little bit. You thought that it might shift it 2 to the right, but it only shifted it 1 to the right. That's because this whole thing has been compressed by a scale of 1/2. It has horizontally been squished. That's the difference between vertical and horizontal compression and expansion, or stretching. So quickly we'll show you what happens with the 1/2. Let's go pick a good value of 2, because we can easily take half of 2 would be 1. 1 minus 2 would be a negative 1 squared is 1. So 2 is going to give us our 1. But now let's go all the way over and let's pick a 4. Because half of 4 is 2, and 2 minus 2 is 0. So that's where we get our horizontal stretching, because it's a fraction. So remember, the stretch value is opposite. It's the reciprocal of a. So we're stretching this horizontally by a scale of 2. And this graph is going to get much wider in terms of horizontal stretching. Okay? So it's really difficult to see the differences when you're talking about vertical and horizontal, but that should help clear it up a little bit. So the last one, we're just going to mess with a whole bunch of stuff. So again, we are in vertex form. So 3 to the right and 8 up is going to tell us that our vertex is at 3, 8. And now we're going to have a scale of -2. It's on the outside, which means we're going to multiply all of the y values after we substitute an x in by a -2. So this is going to open down, and it's going to be stretching much faster. Okay? So this graph, after you plot a whole bunch of good points, is going to start at 3, +8, because our vertical shift is 8, and our horizontal is opposite of what we would think at 3. And we're going to open down because it's negative and stretch it vertically by a scale of 2. Okay? So I know that was a long video, but there was a lot to talk about with the different types of transformations of quadratics. So this is Longo and I'm out. See you, bye.